like in 1990, or did you come even earlier?
92.
Oh, 92. Oh, so I had the pleasure of being with him only for a year and a half or something like that. Then he went to Columbia University and then to Carnegie Mellon, where he got a PhD under John Lafferty. And he's now a founding member of Ocelot Corporation. And he's going to tell us all about what they're doing.
I was. Thank you. Thank you, Fred.
In perspective, this talk has been looked at by the lawyers.
Well, okay. Right, so a couple of you have heard, I'm going to tell the abbreviated version of this melodrama before I get started, because some of you may have read the abstract and feel like you're in for a little bit of a bait and switch, because this is not what was advertised in the abstract. Yesterday at about 4:30, I got a call from, I work at Ocelot Technologies, and I'll tell you a little bit about that in the second half of the talk, but I got a call from one of our attorneys who said, well, you can't talk at Hopkins tomorrow about that. I had shared with them the presentation that I was going to give today. That's no good. So that was very convenient for them to tell me, at 4:30 yesterday, and I had to get in the car this morning at 6 or 7 to get here. So I scrambled last night, and I decided to instead make the best of a bad situation, and I'm going to give two little talklets, which are actually related in a way that I hope you'll see. Is talklet a word? I don't know. I just coined it.
No, actually, you coined it this afternoon. You already.
Right. I think
the word to me.
I think I made that word up in the car on the way over here.
Yes.
It's great to have a 4-hour drive. You can think of all sorts of neat new words and stuff. So just to give you a sort of very coarse outline, the first talklet, now that it's a word I can use it, is on some work that I did in my thesis, which has to do with non-extractive summarization and machine translation, all jumbled into one. You'll see what I mean. And then the second part of the talk is sort of an overview, an emasculated overview, if you will, of what the kind of problems are that we're looking at Ocelot Technologies, which is a company that, as Fred mentioned, I'm working at in Pittsburgh. So I'll start with this prototype that I developed along with a colleague, Vibhu Mittal, who's now on the West Coast of Google. At the time was at Just System Research in Pittsburgh. In case you're wondering, one person already asked me, an ocelot, I may be pronouncing that wrong, is an endangered southwestern feline, about twice the size of a house cat. And there's no reason why this system is called Ocelot. Just like there's no reason that Google is called Google. So the question is, why summarize web pages? This, by the way, an earlier version of this work was presented at SIG-IR in Greece. What was that, 2000, 2001? I'm not sure. Why summarize web pages? So there's a couple of reasons. One is, and you can see there's a little bit of a vintage to this presentation, because I talk about a Lycos query. Now there's only one search engine, right? Nobody ever uses Lycos. But if you type in search or query machine learning to Lycos, or this works for Google as well. I tried it last night just to confirm. You get a couple of hits, a lot of hits probably nowadays, and with each one you get a little summary. But it's not really a summary. Okay, what it is it's the top of the page with some very primitive filtering to get rid of HTML tags and stuff. But that's not really what you want when you want to triage what it is that you want to look for, what you want to look at. So maybe what you really want is some sort of a distillation of what that document contains. That's sort of a justification of why you want to do web page summarization specifically. There's all sorts of reasons why you want to do summarization in general, and I'm not going to go into those. There's another reason you might want to do it, and this occurred to me sort of after about halfway through with the project. This was a couple of years ago, which was, gee, wouldn't it be nice to, a little background, where's my prop? Here's my prop. This is my cell phone, which has a browser, a web browser on it. Yours does too, probably, unless you bought it more than 3 years ago. And since it has a browser on it, wouldn't it be nice to summarize, to distill web pages down to a size that they can be viewed conveniently on the small screen of a wireless device, like a PDA or a cell phone. Well, that will be a recurrent theme in this and the next talklet. Okay, so extractive summarization. There's a whole ontology of terms in information retrieval and in summarization specifically, which I'll give you a brief overview of. I don't know that much myself about it, but extractive summarization is actually not what we're doing. But just to contrast it, that's the kind of summarization where you take a long article and you summarize it by extracting, right, phrases and sentences that are representative of the document as a whole. Okay. And in some sense, so this works great for like news articles. Here's a news article off the AP Wire about Sony's PlayStation 2. You know, well, way back when I was in college, I worked on the college newspaper, and they teach you how to write in an inverted pyramid form, right? So you say the most important stuff first, and then you flesh it out a little bit more, and then it's not inverted pyramid, it's a real pyramid, I think, actually. I don't know why they call it an inverted pyramid. You say the most important stuff at the top, and then you in the first paragraph, and then you sort of flesh it out, and by the time you get to the bottom, it's sort of the little details that nobody even really cares about in the story. The point is, to summarize a news article, it's trivial. You just cut at the length that you want. I mean, I'm oversimplifying, but basically it's a very simple problem, I would assert, extractive summarization on news articles, at least relative to the problem that I'm going to talk about. So the point is here, like, if I want a 50-word summary, I'll just cut off here. If I want a 100-word summary, I'll cut off here, etc. That's the algorithm. But what about summarizing hypertext? That can get a little bit tricky, and it requires, this is an assertion, synthesis, not merely extraction. How are you going to extract anything useful from, for example, that? You know, what do you grab onto?
What do you want to extract?
Right. Another question. Maybe there is no good summary here. Maybe there is no good summary here. I think
shopping for toys.
Shopping for toys. I think there is. I would claim. I mean, this is a super hard problem. And I'm not asserting, by the way, just as a forward reference, that the system I'm going to describe solves this problem. But just as an example, there's just no way that extractive summarization covers all cases that you would want to, in principle, summarize something for. And I would also assert that, yeah, a summary would make sense for a website and the summary would be something like, you know, someone said it, buy toys for kids or something, buy toys. Okay, so let's talk about an approach to summarization, learning to summarize. The idea here is, this is sort of a high level, is you find a large collection of web pages and their summaries, and from this collection of pairs, learn a mapping from the document, the web page, calling it D, to the gist, G. So D is, I probably should have used W and S, but I'm using D for document, web page, and G for gist. And because I'm just that kind of guy, the mapping will be probabilistic. You'll see we use a statistical framework for doing this that's derived from the machine translation techniques that are in the literature. So I talked about a brief tutorial, this is it, on the sort of the world of summarization as I know it. And this is sort of thanks to a guy named Dragan Mirado who explained this to me at SIG-IR a couple years back. So there's extractive and non-extractive. I explained what extractive and non-extractive were, right? Non-extractive is where you don't. Extractive is where you grab sentences or phrases out of the original document and use those to build up your summary. Non-extractive is where you don't, where you synthesize a summary, perhaps using words that weren't even in the original document. Like, for example, there may very well be a document on baseball which doesn't mention the word baseball, but it's really all about baseball, and so you should really use the word baseball in the summary. And inquiry independent, inquiry sensitive. There it's like, well, if I'm typing in, if I typed in a query, then I might want to project all the documents that are relevant to that query and give a summary of the document with respect to that query. Like, there might be some really long document, parts of it relate to my query. I want to summarize how that document is related to my query. That's not what we're doing here. What we're doing here is just sort of projecting a document down to a distillation of it independently of what the user's specific informational interest is, or expressed interest. So we are there. Okay, so what the starting point, I should explain the title here. There's this expression that we were fond of at IBM. I don't know, I think it was, maybe it was one of the Delicators actually that made it up. Maybe Fred remembers it. If you have a hammer, everything looks like a nail. So this was actually applied to, sorry?
It's Karl Marx.
Karl Marx? Was he the one who originally invented it? Okay. That's not, I didn't hear it from Karl, by the way. So I heard it from one of the Delicators. I just don't know which one. That's interesting. I didn't know that. So the idea here is statistical machine translation is a very powerful tool, and the techniques that were developed in the paper that was reported here are actually of much broader import, I would propose, and I'll prove to you, I think, than just for machine translation. So that's the hammer that we're going to bring to this problem. So you when you're doing, obviously when you're doing statistical estimation or building statistical models, you need training data. And in some sense, I was talking to somebody this morning, I was saying the last 6 projects or 5 projects I worked on in grad school were, I found a cool data set. And then the first 4 projects I worked on in grad school were like, I had this hammer, which was either translation or, maximum entropy, estimation or something like that. And I said, well, gee, here's a hammer, where's some nails I can solve, what problems can I solve with this hammer? And then the last 5 problems in grad school were more of the form of like, gee, that's a really cool data set. I wonder what we can do with that data set. And this was definitely in that latter category. I stumbled across this open directory data set. I don't know if you guys are familiar with this, but it is just like a golden resource. I guess more and more of these kinds of things are now becoming available, but this was in the late 90s where, and it was just great to find something like this. What it was, actually at the time it was less than 3.8 million. Now I just checked last night, it's up to this number now. 3.8 million websites, URLs that is, each categorized and summarized by a human editor. So they've got this big ontology, okay, a tree of categories, and you have these human experts, volunteers, who find web pages that are relevant to their categories and put them in and give a little summary of the web page.
Really?
It's great. It's just gold. I mean, you can do so many cool things with this.
The best way to search it is click the directories tab on Google.
Right.
The directory tab on Google. Google indexes it with PageRank.
Mm-hmm. Right. It's all available in an RDF dump. So RDF is just this markup language. It's, so you can easily massage it using your favorite, Perl filters or whatever. And just to give you a sense, if you haven't been exposed to the data before, of how fine-grained it is and what the summaries look like, here's from science, technology, mining, prospecting, that leaf in the graph. Here's a couple. I think this is just like the beginning of the A, just the A's or something, just the beginning of the A's. So it's very rich, and those are the summaries. So now what I'm going to do is I'm going to walk through 3 progressively more, I would assert, interesting models of gisting, and nothing. And so the first one is bag of words, and then synonym aware and readable. The bag of words gisting, bag of words is just the way I refer to unigram model. I don't know if that's a term of art nowadays, but you've got a distribution lambda over words in a document. And the idea for generating a gist of a word is you select a length from a length distribution. You've got some distribution on lengths of gists. And then for each position for each slot in the gist, you just sample from the distribution from the document. So you have this bag of words model, and you just sample from that. Okay, so that's what this little guy from this cookie jar is just picking words out, laying them down in the gist. It's a very primitive model, and the document from a document, probably the person who produced the summary is very straightforward. It's just the product of the two terms, the length term and the individual probabilities, word probabilities. This has problems. One, the summaries are not likely to be coherent. I mean, coherent, I use the word readable and coherent interchangeably here. In other words, the words were just put down randomly, so they're not going to make any sense together. It's not trainable. We're not using the open directory data set, so kind of wasting that resource. And the summaries can only contain words from the document. So this example I gave before about baseball, right? If there's a news story that talks about opening day and home runs and I don't know, what are the other words about baseball? But you might not mention the word baseball. In fact, I would guess most of the articles of baseball don't actually. The summary can't either. The gist can't. Okay, so that's no good. So let's solve that last problem first. Okay, the synonym problem. So now the model is, we do another step in the generative process. Instead of just, I wish I had a pointer. Well, I have my finger, that's like a pointer. Instead of just picking a word and then laying it down, we've already picked the length. Now we take that word and we pick a synonym for it. So we have some sort of a model, a synonymy model, okay? And this lets us sort of a smoothing process. It lets us, replace a word that we drew from the document distribution with another word, okay? And then we lay that down in the gist. So sigma, this statistical synonymy model, is going to be some stochastic matrix, n by n, very simple model of quote-unquote translations. I shouldn't have jumped the gun. Shouldn't have used that word yet. On the diagonal is the probability that word I goes to word I, and those are going to be pretty high probabilities. And then there's going to be some off-diagonal probabilities as well. And somehow we have to estimate this matrix. And so that was the gun that I jumped. So the way we do this is we can use, now here sort of for the sake of time, I'm going to have to refer to something which, you can go off and read if you don't know that, but it's that article that I mentioned before on methods of statistical machine translation. The mathematics of statistical machine translation is a sequence of 5 models there, which are parametric models which describe the translation process. I just don't have time to go over each of them, so I'm just going to invoke them, or invoke the first 3 actually. So what we do is we use model 1 here to estimate the maximum likelihood values for this matrix, well, smoothed actually, from that.
What's the matrix again? What does it have?
Word translations, but here's the thing that's a little confusing. It's English to English.
Yeah.
Okay. So it's like think of it this way: the language of gists on one axis and the language of documents or web pages on the other axis. Okay.
And you use the data set that you.
Yes.
That
You'll see. Actually, yeah. You're predicting the next slide. I think. Let me see. Yeah. So I'll describe that now a little bit. And then if you still have a question after this slide, ask me again. So the idea is you start with this uniform sigma model, quote-unquote synonymy model. It's not quote-unquote, it's a quote-unquote translation model. It really is a synonymy model. And then you just accumulate counts, and now the counts are, the D and the G's should give it away a little bit here. It's the probability of the document given the gist. And these are just EM training, standard EM training. And that's the count, it's the EM count. And then, so it's the EM, you just EM train this. So these are maximum likelihood estimates in that matrix. Yeah. I said smoothing before, but actually there is no smoothing that's going on in this case. So what we did was we used, so does that clear up the question? So we used 100,000, a little more, page summary pairs, web page gist pairs from the Open Directory data set, just downloaded them. The normalization was very lightweight. As you can see, I'm just showing you the actual filter we used. And there were about 25 million words in the web pages and 2 million words in summary. It's actually surprising. You might think the web pages would be larger than like, what, 12 times bigger than the gists, but most web pages don't actually have that much text in them. If you run links, I don't know, links is not very many people's favorite web browser, but if you use it, you'll realize how lightweight most web pages actually are. There's a lot of images and stuff. Makes the problem a lot harder because the human brain imparts semantics to the images, but that's all gets stripped away in this. So anyway, here's some of the.
And the images, don't they have a tag? I mean, or the images must sometimes are really random numbers or random.
If they have alt text, we'll take that. But we won't talk about URLs or file names or anything like that.
File names. Yeah,
no, we don't do anything like that. No, because that would probably be like iteration 2 of this project, and I only did iteration 1. So, but there's all sorts of that should be kept in mind. This is I mean, there's prototypes and then there's early prototypes, and this would be considered really just like a stake in the ground. It's an interesting idea that really wasn't evolved along any of the axes you might naturally think to proceed along. So, just as an example of some of the synonymy models, the word in bold is the document word, and the word from the document language, and then the words not in bold are the words from the gist quote-unquote language. So we can see how we can draw a word from the document distribution like camera, and then replace it by a word like photo, for example, with a probability of 1/50. Yeah. So now that solves, quote-unquote solves, the problem of synonymy, or addresses the problem of synonymy. We still have this other problem, is the gists are not readable, or they're not likely to be readable anyway. They're just laid down independently of one another, the words in them are. So now we perform the old Bayesian rewrite trick. which is to say we're before looking for the gist that maximize the probability of the highest likely gist given the document. Okay, that's our max sub g of p of g given d. But so we just rewrite using Bayes' rule. I hope this is familiar to everybody. And we say, okay, now instead suddenly we're looking for the gist that maximizes the product of p of d given g and p of g. There's a prior term. Here's the way I impart meaning to these two terms. This is a fidelity term. The how close the document is to the gist, and the readability term of the prior term is how what was the word I used before? Coherent the gist is. And so, I don't know, some people like to jump through hoops to try to justify these things using source channel models, and I'm one of those people. So let me just take a stab at it. So you can imagine, if you want, that the so now, okay, we've got a document and we want to generate a gist from it. You can imagine that the document is a web page. The person who wrote that web page, they originally had some idea. They woke up in the middle of the night and said, I'm going to write a web page about I don't know, the San Diego Zoo. Okay, so so the idea was a web page about the San Diego Zoo. That was his idea. And then he went off and he wrote this web page. And so the corruption of his original idea into the actual instantiation of the web page was this noisy channel. Okay? And the original idea, which we're calling a gist, was, quote, what did I say? A web page about the San Diego Zoo. So the P of G term is just prior on all ideas that people might wake up in the middle of the night with and decide to write web pages about, and then the observed document. And then the P of D given G is just a model of the channel. And then the decoder's job is to find the model, find the gist given the web page, which maximizes those two terms. So I don't know whether I jumped through the hoop or not, but it's a reasonable argument for, you know, for flipping around the terms. And this should be familiar to just about everybody. What do we use for the prior? We use a trigram language model, nothing special here. And for decoding, we just use so now what we're doing, remember, we've got to apply a stack decoder to try to find the gist that's the gist given the document that we have. And we've got all that training data, which we've already trained. So we use the Viterbi algorithm, and unfortunately, just in the interest of full disclosure, and this shouldn't be surprising also, when I ran these experiments 2.5 years ago on this was a top of the line, well, like $100,000 Sun machine, Ultra Spark, with 6 processors. It took about 2 minutes, or a minute to 2 minutes to run to generate a gist. So it's not a real-time process.
It's real-time. You can do it faster than they write it.
Well, I'm sort of applying Moore's law here. I'm assuming that now it would take 10 or 20 seconds. And that's probably unfair. It's probably a little more than that. So. Would you be willing to wait 10 or 20 seconds?
When you're doing speech, real-time means that you can keep up with the output. And you can surely keep up with the output of somebody writing a web page.
Oh, real-time in speech? Yes. Okay, sure. Yeah. Then it's you know, sure. Well, I mean,
if the documents are summarized, they're written as opposed to when they're retrieved.
So, since it's query independent, right? You don't have to wait for them to come down the pipe from retrieval.
Right. That's true. That's true. You don't, except that the application we always imagined was no one was going to ever be able to keep up with all the web pages that are generated. So the only ones that you would actually summarize are the ones that people ask for. You're right. That's a good point. I didn't make that clear. That's the reason we conceived that this is real time. Because even back then, 2 years ago, when this work was first started, there were terabytes and terabytes of web. I don't know how many web pages out there, but too many.
It's certainly important to make it fast. I mean, because this would be much slower than anything that Google currently does to a document.
Yeah, right. So this is not, anyway, so I think we beat that to death. Point is, we all know of ways to make these things more efficient, but that's another axis along which this needs to be developed. And now the tricky thing about summarization is it's sort of like the opposite of speech recognition this way. There's really very few reliable, well agreed upon ways to evaluate whether a summary is good or not. There's intrinsic, which is you just sort of stare at it and scratch your chin and decide, well, gee, that is a good summary or not. And that's people do that. And I'll show you one, and you can decide whether you like it or not. And then there's extrinsic, which is to say you embed the summarization task inside of another task. you embed the summarization algorithm system inside of another task, and you see how well the person can do that task with and without the summarization system. You'll see what I mean when I give an example.
So ultimately, a human decides whether it's good or not. You're saying.
In the first case, in the intrinsic case, the human decides whether it's totally subjective. In the second case, it's like how well can you do at a certain task with the help of this.
Well, even the first one, you could have some kind of automatic measure. You might have some gold standard summary.
I've seen people using precision and recall for these things, like, well, gee, there really should be these words in a good summary.
When I meant an intrinsic and extrinsic doesn't have to do with human, it has to do with evaluated in isolation.
Yeah, that's right. That's right. You're right. Good point. I was conflating those two. That's right. That's right. So this is not fair, and I'm actually embarrassed to even put it up, but I just as a representative, or not even that representative sample, here's a web page, and I put the images in here, but you really should mask them out when you think about the summarization task. And here's the gist from the system that I described, the not model 3, the third
So
version.
the gist is automatically generated from the statistics
Yes.
that are there.
Yeah, right. So, and of course this was, part of the test set, so it wasn't used in training.
So this is a realistic gist for this page?
It's a what?
Is a gist for this page?
Yes, it's a gist for this
How
page.
come? There's no word jazz or rock in this.
Well, that's the beauty of the...
Synonyms, they're synonyms of something and they go.
Music.
Right. I'm not saying this is good. I'm saying this is an actual live output of the system. Actually, it's better than most of them. So just so you know. So I mean, the problem is the trigram model is not great. The model of synonymy is not great. There's a lot of things that need to be evolved in this system. So, and then but wait, you haven't seen it yet. So we then performed an extrinsic evaluation, and this was actually, I think, very, very useful to do. So the idea was this: had to think pretty hard about how to evaluate the summarization system inside another task. So what we did was we said, okay, well, remember the Open Directory data set. Each one of those web pages falls into a category in the Open Directory ontology. And so let's pick out a couple of categories, these categories. 3 from, what do I have here? 3 from sports, 2 from society, 1 from home and gardens. So there's a little bit of confusability, I suppose, in like some of the sports ones, and then the society, philosophy, and military, and then hopefully the home and gardens would be really kind of hard if we confuse some of those with some of the other ones. But I just picked those out myself, actually, from the ontology. And what we did was we took 630 web pages and their gists from the test set, and from these 6 categories, and we asked 6 human subjects to do the following task, to basically take, to try to categorize into one of these 6 categories, 630, either web pages, or just using the title of the page, or using the gist that Ocelot, the system, provided, or the Open Directory created gist, or a bag of words just from the original, drawn randomly from the original page, or the first n words in the page. Okay, so those are, think of these 6 as like 6 different noisy filters that are applied to the original web page. And what we're basically asking which one of them is least noisy. Okay, because that's probably, I'm taking too many liberties in saying that, but the idea is, how hard is it for a person, or which one of these is best for is most useful for a person who's trying to do the categorization. So here's an example. So the full text of the web page for this random web page, davidcoulthard.com, that's the text. Remember, we did text normalization, so the case doesn't matter. Title of the page, Ocelot gist. That's not a great gist. The Open Directory gist, which isn't much better, actually. A bag of words selected uniformly at random from the original page distribution, and first n words of the page, where n is the size of the Ocelot gist. So there, now we get some results. You can think to yourself before I show you what the results will be like. But what I was afraid of was that the Ocelot gist would be at the bottom, which it's not. But what I was surprised was what's at the top, actually. So you might think that the web page should be at the top because it has the most information, right? But actually, I'll give you a hint, it's not. The one that's at the top, well, we'll show you. The one that's at the top is the open directory gist. And this actually makes a lot of sense after you think about it.
To see what an open directory gist looks
The
like.
human created gist.
Yeah.
It's the one that the human created.
Yes.
Does anyone know why this would be?
Annotator agreement.
Yeah, I mean, the same guy who created the gist was the guy who put it in the ontology. So, right, if he was, high on drugs when he did it, it doesn't matter because, right? If you know what I mean. So you see, we do well better than the randomly selected words, yoo-hoo, but not much better, and almost as well as the title of the page, but not anywhere nearly as good as the open directory gist, and not as good as the original web page. This is about what I expected to see for this first cut of this prototype. So, just show you a little bit of related work, and then I'm going to take a little break and go on to the second talklet. Well before my time, this guy, I don't know how to pronounce his name, in 1982 created this FRUMP system, which is relevant because it does information extraction and then generation, which is sort of, in a sense, what we're doing, generation. And Jan Peterson was my external committee member, so I always have to acknowledge this paper. The Trainable Document Summarizer, I think this was the first, so far as I know, the earliest paper that actually talked about training summarization systems statistically. But it was extractive, not non-extractive. Then the first article that I know about that was non-extractive, and I could be wrong on the prior work here, I might have missed something, but the first one that I know about is Whitbrock and Vibhu Mittal, and Vibhu, remember, is the co-author on the paper that this work reports on. Did this thing called ultra summarization, where they were working on text news stories. And they didn't have any idea of using synonymy. They weren't really doing machine translation in that sense. And then actually, work that cited this work that I found by just doing Google was some work at Stanford. And this is interesting because they are interested in shrinking web pages for viewing on PDAs, which is that second application that I talked about. Okay, so let me stop there, and put a little seam in it, and then we'll start up again. But I'll take questions about this first part. Yes?
Unrelated work, there's a paper that I'm surprised to see omitted, maybe you don't know it. It's the Knight and Marcoux paper from 2000, which is using a technique, I think, identical to yours, but on the level of sentences rather than entire documents. Is it not identical?
Yeah, right. I remember the Marcoux paper, actually. And I don't remember why I didn't include it. I think it was just an omission. Yeah. So no, there's no good reason why I omitted that. Summarization is a really, really active field.
I don't think they had your nice idea of evaluating it on text categorization. I like that very much. So I don't know how easy it is to compare. But what they're doing is somewhat different in intent because they're applying it to single sentences, not whole documents.
Right.
Sentence compression is the subtitle of the paper.
Right, and they're picking out, are they doing more than picking out, well, I have to go back and look at that work again, because I remember reading about it. I'm not familiar with it.
They use Model 3 or something. I don't remember.
Okay. Yeah, so no, there's no good reason why I didn't. Okay, other questions? Good, so, I don't know how often you get 2 talks for the price of 1. How do I say how I do this one? Okay, so now, remember I mentioned, what's so funny? You got to see my
desktop. You're in industry, but the title sounds like something out of Dartmouth.
I struggled long and hard with this title. I had a much better title before, but I told you it got emasculated. It didn't make sense to talk about, interesting problems and their solutions, in mobile data access, because I'm not going to talk about the solutions, I'm just going to the problems, unfortunately. So be it. So remember we talked about in the second application, which was repurposing web pages, summarizing web pages for viewing on small screen devices. Well, that actually, the work that I just described was actually chapter 4 or 5, I don't know, of my thesis. And then I graduated and I started a company with a couple of other guys called ISO Technologies. And we actually decided we were going to solve just that problem. We were going to summarize web pages for viewing on small screen devices. We're going to sell this technology to like Sprint and Verizon and let them provide it to their customers so they can view web pages on their phones. Great idea, right? Yeah, so it turned out very quickly we realized that that's not what people want. But by then we'd already started the company. So I'm going to talk about some of the problems that we really do face at Eisel. It's sort of, well, that's not this talk, but I certainly learned a lot as well along the way. So if anybody wants to ask me offline about if you have any ideas about starting a company, I can either encourage or discourage you depending on my mood. I have strong feelings both ways. So the problem is this: how do you get these kinds of documents? Now, web page is one, but there's others too. Also, how do you get these kinds of documents on these kinds of devices? So I'll talk about both the documents and the devices. Oh, I've got plenty of time. The document, hypertext document, great. There's, I see 4 columns there of different stuff. I see some navigation links here and embedded images and logos and all sorts of interesting stuff, different colors and different fonts. And then I've got, it's hard to see, I think, but there's a legal contract and which is in Microsoft Word format, and there's a PDF file, which I think is a resume. And then on the right, there's another PDF file, which is like some sort of a technical article about the semantic web. I just haven't memorized. We've used it in other examples before. And it's also 2-column, and then on the bottom it's 3 columns. It's got an embedded image, embedded figure. It's got a little image on the top, which is the author, and a caption underneath that, border. It's got everything. I mean, it's very much exploiting the 2-dimensional aspect of the page. Okay, but these devices down here really are linear. They are 1-dimensional, or they may be 1.5-dimensional. Okay, think of it like you ever been to Times Square and you see the ticker tape going past, and it's just really a 1-dimensional view of information. Okay, there's no sense in which you can exploit multi-column text or any sort of visual, elements like that there. And here, these kinds of devices should be thought of more or less in that sense. Maybe a little less so that handheld computer, but even there, it's not. You don't have the full 2-dimensional view that you do on a phone, on a PC. So there's a dimensionality reduction problem that we're facing. Another way to look at this is as follows. A PC has about, depending on how much you want to spend on your monitor, but about 90 square inches of viewing. And a Palm Top and a PDA have about 10 square inches. And those are the best, right? So then you've got a WAP phone, which has, what, like 1 or 2 square inches. Any more than that, and it just doesn't, there it is, doesn't fit in your pocket. And that actually turns out to be, that and the power consumption turn out to be the 2 biggest constraints in phones these days. So if it doesn't fit in your pocket, it's not going to be bought. Okay, so anyway, on the right, what I'm showing, and I actually should define porthole also, maybe it's clear. What you're essentially reduced to on a phone when you're viewing one of these things is a small porthole in the original document. Okay, and you can move this porthole around to view the document, but the question, all sorts of interesting questions come up for a company like us, which is, here's one. If a user asks for a document like this, where should we put the porthole at first? Okay, should we put it in the top left corner? Maybe not. Maybe we should put it where the content starts. What's content? Okay, for a web page like this, maybe it's Colin Powell's picture. That's Colin Powell. Maybe it's this headline. I don't think it's up here. Maybe it is for some people. So that's an interesting problem, is detecting the main content in a page, in a web page. Okay, so let me back up a second. I'm getting a little ahead of myself. So at Eisel, the goal that we are striving for is, it's a little grandiose, but it's this universality goal. We want to achieve secure and convenient access to any document from any internet-enabled device over any network. That's like our mission statement, if you want. Okay. And the implications of this are, well, any document, Word document, PDF document, 2-dimensional format, large, it could be hundreds of megabytes, this document. This thing has like 40K memory on it, okay? any network. Well, networks are very, very slow, so am I really going to want to pump down, 400 megabyte file down to here, even if I can? Maybe I want to cache it in an intermediate server somewhere and just send down a trickle at a time. Those are interesting networking problems. Yes?
And the assumption is that you want really a visual display because you know about radio. Radio can information on the radio.
It's not assumed in this mission statement.
Oh,
Internet-enabled devices can be
anything you want.
something that talks to you when you're
exactly
right.
So that's the reason.
Absolutely, yeah. And that's a truly linear presentation of information, right?
And that's still powerful.
Yeah, no, it is. But I mean, there's no sense in which you can show parallel information. So. Okay, so it turns out, I just discovered this like about 2 weeks ago, that you guys all familiar with the W3C? It's sort of one of these standards bodies that worries about information access on the web and stuff. They've got this mission statement in 7 points, and I found out that the first bullet in the mission statement almost exactly overlaps with ISO's, which is confirms that we're not off in the weeds, I guess. Or maybe we're both off in the weeds together, I don't know, but it was reassuring to see it. W3C defines, I'm just going to selectively be part of it, defines the web as a universe of network accessible information, and then we talk about a computer, phone, television, or network refrigerator. This idea of network refrigerator is used over and over again. Samsung happens to sell this this refrigerator with a display on it, and everybody thinks that's the way of the future. I don't, but, and I'll go on record.
Refrigerator with what?
A screen on it, Fred.
A screen on it with internet access. You can hook up an Ethernet cable to the back of the fridge. It'll order your groceries for you. Yeah, I know. I'm with you, but. You mean your fridge doesn't have internet access on it?
The funniest thing I've seen is a toaster with a internet access where it gives you the day's weather. It toasts your bread either with a sun or a cloud. I'm serious.
Really?
Depending on what it's going to be.
Well, okay.
Let's continue.
So I actually have a slide at the end which talks about some things that are happening in the future, and it doesn't mention network refrigerators or toasters, but it does have some things which I think are genuinely interesting. So, okay, let me continue. So one of the W3C's primary goals is to make these benefits available to all people. This book gets interesting, I think, or the overlap is significant. Whatever their hardware, software, network infrastructure, that's exactly what I just said, right? Because I said any document, any device, any network. But then they go on. This is where it gets, I think, really interesting for this audience specifically. Native language, culture, geographic location, or physical or mental ability. Well, I'm not sure. I think they should have ended a little earlier, but maybe they should have put the period a little before. But there's something really interesting here, isn't there? Right? Because they're saying we want to deliver. Okay. That's what everybody here actually does, in some sense. You want to create a mediating element, mediating technology, which allows people who are operating at one end, the consumers of information, to consume the information that they want, despite whatever assumptions were made by the producer of that information. For example, I think in my next slide talks about this in more detail. Okay, so the producer of the information is using a 21-inch screen. It's got a gig of RAM, it's got a very fast connection to the internet, it's got 32-bit color depth, and the person happens to be a native English speaker. Okay, I didn't just slip that in at the bottom, it's important. The consumer of the information happens to be operating on a 2-inch screen with 16 megs of RAM. That's generous, actually, these days. Won't be next year, probably. A CDMA network, 1X network, that's sort of a high speed, but still pathetically low speed compared to 100 megabit Ethernet internet connection. Because wireless connections are inevitably slower than, the fastest wireless connection is much slower than the slowest wired connection. 4-bit color depth, and it's a native French speaker. So now, what we really need to do, and this is ISIL's mission statement, if you remember back to it, any document, any device, any user, any network, overcoming the impedance mismatch between the producer and the consumer of the information. That's the big vision, right?
Reminds the IBM commercial with this connector.
Right, a universal. This is the pixie dust they were talking about. No. Yeah, right. But only. All right. So the next slide. Well, you're giving me a forward reference. That's fair pushback. You'll see where I address that next. You'll see where I actually explicitly limit our scope. But it's good to carve out a huge problem and then say, okay, I'm here. And that's what I'm sort of saying. I'm saying there's this huge problem, and we're going to be in here. But in general, anyways, why not think about a network element which does all of these things for us? And you know, machine translation is part of it, right? I'm on my phone and I'm trying to view a Word document that was generated by somebody who expected me to be on a PC and be able to read Russian. Okay, and this guy in the middle takes care of all of that. So okay, so that's the grand vision, and then let's be a little more modest here. What we're really worrying about now, and the sizes have no particular meaning here. There's all producer-consumer mismatch problems, and we're worried at Ocelot about these two, the union of those two sets, which is the high capacity to low capacity display, okay, PC to cell phone, and the high bandwidth to low bandwidth. PC to, sure, to a wireless device, but also PC to a laptop that's dialing in over a very low speed, you know, connection, for example. And then of course the overlap of that is the PC to mobile. And there's other things in here too, like, you know, text to speech and so forth. Okay, and those are also in this Venn diagram, but we're not worrying about those now. But someday we might be. So let me just say a couple things about what you would see if you used. I can show a demo to some people if they want to see it afterwards, but I don't have the equipment to show it to everybody here. So I'll show some screenshots instead. Here's a CNN webpage, actually I went a little bit too fast there. So one of the things that I mentioned, I'm just going to give a sort of a brief overview of a couple of the things that that we do to overcome the producer-consumer mismatch when you're viewing something like a web page. One of the things is, remember, there's very limited memory on these phones, okay? And such that you couldn't actually fit this entire web page, which is maybe 100K or something, into that phone, all in one shot. Not that you would even want to, because the network is so slow that it would take forever to send it down. So what we do is at a network element in between the website and the phone, we'll essentially we'll parse this document, the web page, into two parts, or multiple parts. I think actually 3 parts. This is part 1 here, which is shaded. That's the navigation, the logos, the maybe banner ads and so forth, that'll show up there on that phone there. But also part 2 starts right at the main content with this web page. I mean, so with this picture here and then the top story, and that's part of the technology is trying to figure out where the main content is. This is one of the core problems. Wouldn't it be nice, as I said before, to be able to jump the user right to the main content when they access? Yes?
That's actually an easy example, because already CNN does it for you. You know, the first sentence there right after the picture usually is the entry to a longer article.
It's even easier because CNN, they actually, for disabled access, they have a little hidden link at the top of the page that says, click here to go to the main content. Yeah. And if you're like using a...
so I mean, I guess this is just an example.
Yeah, right, so and I stole this from our marketing people who like to use CNN because everyone listens to CNN, but it works equally well on other sites that don't have those crutches. But it's not perfect, it's pattern recognition, obviously. So we call this the cut to the chase algorithm, right? Because it cuts right to the main content. So without cut to the chase, a phone would show. You can start up here. Remember, I had that little porthole example where I said you could start up the top here. Now, if you started here on a phone, you would have to kind of visualize what the HTML source corresponding to this probably looks like. You would have to probably go through here, go through all those navigation links, and then maybe eventually get down to here. And so what you'd prefer, what a user would prefer, would be able to start right there. I don't know if this is actually visible to everybody, especially in the background. But see, the point is, the second one, the with cut to the chase, starts right here. Okay? This is actually part 2 of 8 on the right, and this would be part 1 of 8 up here. So the idea is...
where it is from.
What?
You don't tell the reader where it is.
On the first one?
The second one.
No, we do. It's...
I guess you can't see.
You can't see it. It says, it's kind of small. 2 of 8. See, it says 2 of 8?
Oh, yeah. Okay.
We don't have it here. That's because I scrolled down a little bit on that. Or whoever took that screenshot scrolled down a little bit.
Page 2 of 8 pages.
Well, actually, the way to think about this is that this web page was broken up into 8 parts for various reasons, to accommodate the network speed, the memory and stuff. And we jump right to part 2, which contains the main content.
So you don't summarize here?
Absolutely no summarization.
Yeah.
Now, but that's what I'm going to get to next, actually. Instead of summarization, I thought I had a slide in between there. Yeah, instead of summarization, what we do is, I call it lossless condensation. I couldn't find a better word for it. It's not compression and it's not summarization. We've discovered that users don't want their web pages summarized. They don't want their emails summarized for them. What they want is they want something that's lossless. They don't mind, they would love to have the density of their information improved on their small screen. And that's what we can provide here using various different techniques. For example, lexical abbreviation, democratic goes to DEM period. That's just a set of, just a lexicon that somebody at Ocelot put together for English, and it could be put together for another language as well. Those get applied. Algorithmic, minority, where's minority? Oh yeah, it doesn't even appear here because the point is we've compressed more information, we've compressed enough information here that we're getting more on the screen on the right than we are on the left. This is sort of without compression. Anyway, that would say minority in the original. It's a very simple algorithm that works in English and may work in other languages as well, which is just basically remove the vowels. It's a little more complicated than that, but not much. And then the third one is learned abbreviations. This is a little more sexy. It's basically, if you see a word like multiple times, like a proper noun like dashel, the first time you see it, you abbreviate it. You say, okay, this is what the abbreviation is going to be, and later on you use the abbreviation. So you pay an upfront hit first time, and then for subsequent times you only have to use the D. People, whenever they see this screenshot, they always think that the system somehow figured out that Tom Dash was a Democrat on the right, because there's no D here, but that's not what's happening. Probably should come up with a different screenshot. But you see how that works, and about a year ago, Afghanistan was all in the news, and everybody's really happy was using our product, because instead of seeing all 15 letters for Afghanistan, they're just seeing A, which is nice. So the idea here is, if you look, you see on the left, without abbreviation, you're getting, I don't know, there's about 15 lines on this POM PDA. And on the right, you're actually getting three more lines, I guess. You're getting 3 more lines than you do on the left.
So this is a proxy service. I mean, someone just...
Yeah, the proxy. It operates remotely from the POM.
Is there any way that you can indicate that it's an abbreviation rather than, so that someone, because I can't see it right now from here, but is there a way of telling that such and such is an abbreviation without reading the entire text above?
Oh, right, yeah, so there's a little lookup table that you can access, which says what all the abbreviations are. You have to basically, you can't see it from here, but there's a way to do that. The server stores all those abbreviations. It knows because it's generated.
So the user that's looking at this knows, would know, oh, I'm looking at an abbreviation.
Yeah.
You can then double click or whatever to...
Basically, that's right. Basically, that's the idea. Is there a question in the back? Okay. So I just want to make sure this is clear. Condensation is not summarization. Okay, so actually this slide is sort of a legacy from when I wasn't planning to give the first part of the talk. So I'm citing some of the stuff that we mentioned in the first part, right? That was summarization. And we found mobile users want all the information out of the gist of it, which was disheartening to me because I thought it would be really neat to apply that stuff. But all the better, it wasn't real time anyway. And it's not compression either because remember, well, I shouldn't say remember, I haven't told you this, but this is all operating within the web browser of the device. I implied that, I guess. And so, the only decoder, such as it is the human brain that's watching it, right? That's looking at the text. So we can't use something like lemple-ziv and then have a decoder on the other end, right? We can't. I mean, we could, but then the user wouldn't be able to. That's not built into a human brain. So I hope that's clear. See what I'm saying by that? So it's not summarization, it's not compression. I had to find another word. That's why I'm calling it condensation. There actually is a significant amount of previous work. Some of it in the area of web proxies, which doesn't seem related unless you think about it, the architecture of the system, which is, this thing is operating as a web proxy somewhere in the middle between the phone and the content that the person using the phone is trying to access. The first 3 are just different kinds of web proxies that are out there. One is for, anonymizer, if you're familiar with it, is for a way of, people can surf the web without leaving a trail that you would normally leave when you use HTTP. And Squid is for local caching and Rabbit is for compression. These are all, I think, free, publicly available services. And then there's two previous works in them that are sort of more addressed toward making information available to mobile devices. One is called the GlowMop project, and it has to do with image resizing and chunking, and a couple of guys at is that Berkeley or Stanford? I forget. Where's our brewer? I think it's Berkeley. And this actually was turned into a commercial product called Puma Technologies, which was, I think, sold. I don't know what happened to them exactly. They disappeared. And then there's something else called Mauser, which was also somewhat similar to what we do, but it was more involved with pruning content, and I've already said that I think that's verboten, if you ask the customers anyway. But they were similar in scope. And there's another thing that's relevant prior art, and it's a little less clear to see the connection, but I'll try to make it. There's a project at Intel Research that's going on called Internet Suspend Resume. And the idea there is, the way they like to describe it is this. You know how you take your laptop, if you have a laptop, and you close the top of it and it suspends, and then you get on a plane and you go somewhere and you get off the plane and you open it back up and it powers back up immediately and your state is right there for you like it was when you left. All of your applications are still running, your bookmarks are on your web browser there, your email is still there, everything's there for you. And the idea of the Internet Suspend Resume project at Intel was, that's great, but now let's do it without bringing the laptop with us, okay? So how would you do that? You somehow have to store the state of your laptop, of your machine, often some remote server, and make it quickly and immediately available anywhere on any, in other words, you just pick up some machine anywhere, any PC, just be able to click a button and okay, and then your state is right there. That's what they're working on. And that's related to this work that I just described, the stuff we're doing in ISO, in the following sense. You've got a user, rather primitively drawn user, who has a couple of different internet-enabled devices. And the way things are going nowadays, we can pretty much assume that people have a PC that they have access to, and they have at least one or two other internet-enabled devices that they have access to at some times of the day, or when they're traveling, for example. And if their state is stored off in a remote server, which is basically what we do at ISIL, then it's essentially an Internet Suspend Resume, where you have all your bookmarks, all your email, everything available to you off in this remote server, accessible through any mobile device. The Intel project is not so much concerned with making that content available on mobile devices. They're just concerned with making it available on PCs and laptops. That's basically the idea. Oh, and then there's a quote from the Sony president, which sort of says that that's what their vision is on the bottom, if you can read that. Yeah, and so let me just talk a little bit about what Sanjeev, is that your name, Sanjeev? Yeah, what Sanjeev was getting at before with the toasters, which is where are we going here? First of all, this is a really exciting space to be in. Actually, even for somebody like me who had no background whatsoever in networking going into this, or mobile devices for that matter. I've been doing maximum models and hidden Markov models and part of speech taggers and stuff until 2 years ago. But IP-enabled devices are ubiquitous now. There's this new thing called mobile IP, and there's IPv6. These are protocols in the networking space which are essentially granting as a fait accompli that there's so many mobile devices that the 32-bit address space that we've assigned for IP addresses is not going to be wide enough, and we need to expand it to 48 bits. Because some of the thermostats are going to have, and toasters are going to have IP addresses on them. And so that's interesting. And it's a trend that works in the favor of somebody who's worried about the problem of how do you get content meant for one kind of output device onto another kind of output device. There's another thing that's going on, which I don't know if it's related or not, but it's interesting, so I'm going to mention it anyway. It's just sort of showed up on my radar a couple of weeks ago, which is everything is a transponder. There's this thing called, has everybody heard of RFIDs? Or anybody heard of RFIDs? Radio frequency identifiers. there are these little things, transponders the size of a, what is it, a flake of pepper, right? And so you can barely even see it. And Gillette has just bought, like, what is it, 500 billion of them, or was it 500 million? I don't know, some huge number of them. They're going to put one of those in every single packet of razor blades that they sell. And other people.
What are we going to do with that?
Right. So it's not for you, really. It's for the company that is selling, like the grocery store that's selling the razor blades, so they can just track this. The transponder allows it can receive a signal and send back its ID, basically.
Excuse me. So we'll know that this packet has been sold. Is that right?
We'll know
Exactly.
if somebody's smuggling it on a plane.
Pardon me?
We'll know if somebody smuggles it on a plane.
Well, there are, right, so there's scary, like, personal privacy issues that are associated with this that are sort of orthogonal, but the point is it's for inventory maintenance, basically, and there's other applications as well. There's probably military applications that we don't, that they're not talking about. But I'm not saying every, these, it's, I mean, yeah, you know a lot of things. The point is, and then Microsoft's got this Spot thing, which is something a little bit similar. The point is, these are not, I'm not saying your razor is going to have, you're not going to be able to hook up the internet on your razor. That's silly. That's not what's going to happen. What I'm saying is, I'm not sure what I'm saying. I'm saying, well, your razor is going to be, you know, it's in some sense internet connected, like it or not. Those things, those pepper flakes are free, basically. There's another issue which is a little closer to home, which this is something that's already transpired, as opposed to the RFID stuff, which is still kind of emergent, which is, I guess I noticed I have a Wi-Fi card, you know, wireless 802.11 card on my laptop. I noticed I'm sort of getting intermittent coverage here, so I'm guessing that these buildings have 802.11 in them. There was a time about 6 months ago when all of the cellular carriers like Verizon and Sprint, and especially the European ones, were really paranoid that all this money they had spent on the high-speed wireless networks was going to be for naught because everybody's just going to be using 802.11. And now that looks like the opposite is actually happening. I just heard a talk from a guy from Lucent who said that AT&T is not spending a lot of money on 802.11, so they've embraced this. So that the point
802.11 for us who know nothing. What is
802.11 is. This is my 802.11 receiver, transmitter. It's wireless internet access, basically.
Yeah.
Short range, 100 meters, something like that. Relatively high bandwidth, as opposed to, so the point is, these things are low bandwidth, but really high distance, long distances. The transmitter could be, the tower could be 5 miles away. But this tower, so to speak, is a little hub, has to be a couple hundred feet away. But if you get enough of them, dense enough in the city, then you never need the long range cellular. Okay. I think I shouldn't have taken that out as a prompt. So the point is that, what is the point? Oh yeah, the point is that you, nowadays, what appears to be the case is that we're going to have long-range cellular and 802.11 both. And in fact, Nokia now is selling a phone which has both 802.11 and long range. Why is this relevant to this? The point is, remember I was saying I was worried about any document, any user, any device, any network. It's important to remember that not only are devices becoming prevalent, as you've got your refrigerators, your toasters, you've got your cell phones, you've got your TVs, everything is internet connected. It's also the case that they're all talking on different kinds of networks. And one of the problems that we face is making sure that you can communicate on all those different kinds of networks. And I mentioned this to somebody at lunch. Never mind the PDAs, never mind the phones, the refrigerators, the toasters. The only platform that you have to worry about is the phone. There are, I don't know, who knows how many PCs were sold last year? Like maybe 100 million, 50 million, something like that. I think it was more like actually 10 million PCs sold. There were like several 100 million phones sold last year. And right now there's like over 1 billion out there. And you talk a place like China, and some of the other third world countries, in some third world countries, the first time people will ever get on the internet, for most people in the world, what's the statement? For most people in the world, the first time they ever will access the internet is through one of these devices. So this is sort of making the case for this is not this idea of content repurposing is not a fringe application. It turns out to be pretty central going forward. Well, that's where I'll end. I'll take questions if you have them. Mm-hmm.
So I'm setting up. Let's go to somebody else first.
I've also. So two people pass.
They cancel each other
They're
out.
on
But one question. It's pretty clear why people are really anti-summarization for single documents, especially their news documents. You can read the beginning anyway, fine. But is there any evidence that multi-document summarization is also similarly opposed, or have you looked into that? And second, have you taken advantage of actually any query-sensitive summarization or compression, what have you, such as the kind of, one simple example is the kind of location-aware applications that have already been deployed as sort of a way of formulating the query.
Okay, so when you ask the second question, the first one fell off the stack, so ask the first one again. Because my stack is only one deep, actually.
The second one didn't fall off the stack. What do you
Summarization.
Right, I buy the fact that people don't want
Multi-document.
single.
Multi-document, I remember. Multi-document.
Ah, right.
See, it was in there somewhere.
You got 7 or something.
I don't think I do, actually. There's 7 numbers, actually. Yeah, so you're actually, the beginning of the question was, okay, I buy that single document summarization might not be that important for like web pages, people viewing on their cell phones and stuff like that, but what about multi-documents? That was the question, right? So what application did you have in mind? See, multi-document summarization is one of those things where a lot of people, I've noticed some activity in research activity on it, but it's not clear to me exactly what the commercial application of it is yet.
Right, well, I mean, to tie that to, say, the second question, if you have a location-aware process, you want to produce a summary of all the possible services that are available to you in a particular place. It may not be any one gas station or restaurant's webpage, but it's a very simple summarization.
I could imagine that being useful. It sounds a little NLP complete to me. You know what I mean? Like if you could solve that problem, I'm not trying to belittle it. I think it's an important problem. It's one of those sort of amalgam problems, if I pronounce the word right. Like you want a multi-document summarization, as you just proposed it, involves both collecting a bunch of relevant documents, which obviously is already a hard problem, and then summarizing, projecting those onto a query, and then summarizing that in a form that's usable to a person on a cell phone. That's a hard problem. So I don't know, maybe.
Right.
And then and like I wouldn't want to leave out the addresses of the gas stations, right? That's important, right? So I don't know, I don't know, maybe I don't know.
I was just interested in if you come across this problem, not if.
So it turns out, here's the thing I didn't say. It turns out that the thing that people want to do most on their phones is not access web pages. What do you think it is?
Whether
Email. Somebody said it. Email. Yeah, that's like 94% or 95% of what people want to do, and like 0.1% is access web pages. Generally speaking, it's turned out that people want to access web pages on their PCs or the laptops or large screen, and they want to access they have different kinds of information needs on small screen devices. They need their email, they need directions to somewhere, they need to get to their address book. So for their summarization is even less, relevant, I think. So, yeah.
So are you going to tell us how to cut to the chase algorithm works? That's what I was hoping to see in the second talk.
Yeah, I may be able to if you invite me back in the fall. But
yeah, you're just not allowed to tell us it.
I can't now. I could tell you, but I'd have to shoot you, as they say.
I'm wearing my bulletproof badge.
I feel terrible about it. I really do.
Right.
It was a very bad situation, and I'm sorry. But I thought it was better to at least let you know what kind of problems we were thinking about than not at all.
Yeah, indeed. Thank you.
Yes?
Have you thought about summarizing audio?
How is summarizing audio different?
I don't know.
Well, I could imagine doing the following. I could imagine composing the speech recognition transcription with the summarization and then doing it that way. I'm just trying to think if there's specific characteristics of audio that would preclude that or would merit special processing on the second part, summarization.
Your condensation technique is used, something like it is used for audio, where they artificially speed up people's speech in commercials, for example. That's the audio analogy of condensation.
Or for screen readers for the blind, the audio is
Yeah.
very sped up. You hit a key, you know, they read the first few words, you hit the next key for the next one because it's not the one you want.
Yes.
And so forth.
Right, but that's not summarization. I think Bill was asking about, or do you mean like condensation, or do you mean summarization like there's the first talk and the second talk, right? Okay. Let's see.
No, I was just curious if you thought about how interesting it relates to audio.
I'm thinking now.
Is there a need, for example, other people who get lots of voicemail and they want to get it quickly, or they want to hear?
Right. Well, there is that. Right. There's a lot of work in something called universal messaging, which is like you. If you've heard of universal messaging, it's you have one Uber mailbox, which is, I like that word Uber. It's just, I use it a lot actually. It just stores everything: your faxes, your emails, your voicemails, and you can access it from anywhere. And it's sort of like what I was talking about before with the producer-consumer problem. You might access it from your phone, in which case you want everything read to you. You might access it from your PC, in which case you want everything transcribed for you, right? That's sort of getting there. So I don't know. Summarization could play in there. Other questions? Thanks.